Assalamualaikum and a very good day to everyone. My name is Madam Zazalina Zakaria. Okay, for this video, we are looking at digital system and logic. As an introduction, gates are the fundamental building blocks of digital logic circuitry. These devices function by opening or closing to admit or reject the passage of a logical signal. So basic gates type that we're looking at today is AND, OR, XOR, and NOT. For the first gate, we are looking at AND gate. Okay, the spelling is AND. Consists of two inputs and an output. Okay, it also can consist of more than two input as well. The output is 1 only if all or both A and B are also 1. That 1 is referring to true. Boolean symbol is a center dot. This is the example of the Boolean symbols. Below is example how we write equations using AND gate, A and B. On the right side is the sample of truth table for two inputs, in which it shows that if A is true with the number 1, B true with number 1, so the output is 1. If A is true but B is false with value 0, then the output is 0. If A is 0 and B is 1, the output is still 0. And the same goes if A is 0, B is 0, the output is 0. So this means output for AND will only be true or 1 if all input are true or 1. Okay, and below is the how we draw the AND gate. Okay, this is A and B is the input. This is the symbol for AND gate, and the last one is the output. The second gate that we are looking at is OR gate. Okay, we spell it as OR. Okay, two input and a single gate. Okay, single output gate in which it will receive two or more input and the output is still 1. Okay, the output is 1 when at least one or both are 1. Remember, when at least one or both are 1. Output is only 0 only when both output are 0. That means if the condition or the input is all 0 or false, then only the output will be false and 0. So the Boolean symbol is a plus sign. Below are the example how we write the equation using OR gate, which is A plus B. Plus is referring to OR. Alright, this is the example of truth table. We have two input here, which are A and B, and one output, which is Y. So, if A is 1, B is 1, then the output is 1. If A is 1 and the output is 0, output is still 1. If A is 0, B is 1, the output is 1. And lastly, if A and B are both have a 0 input, then only the output will be 0. Okay, below the truth table is how we draw the OR gate. Okay, we have example of two input here, okay, with the symbol of OR gate and one output. Next, we are looking at XOR gate, also known exclusive OR. So how we write it is XOR. Used less frequently than the others. Okay, output is 1 if either A or B is 1, but not both. Okay, it only will produce a one input, one output if only one input is correct or true or 1. Boolean symbol is a plus sign with a circle around it. Okay, the example how we write is, the equation is A. Okay, and then the symbol B. Okay, the truth table are showing two input, which is A and B, with one output, which is Y. So if input for both are 1, the output will be 0. But if at least one input is 1 while the other is 0, then only the output will be 1 or true. Okay, but if both input are false or 0, the output will be 0. Below are the example how we draw the XOR circuit. Okay, it actually looks like a OR gate, but with another one line at the back. Next, we are looking at the NOT gate. Okay, this is the most simple gate. Okay, the simplest gate. Okay, so it has only one input and one output. The output is always the opposite or negation of the input. So Boolean symbol is a bar over the symbol. Okay, actually, the example is as below. A with a bar on top of it, and the truth table are showing only two conditions in which if the input is true or 1, then the output will be 0. And if the input is 0, the output will be 1. And below is the example of how we draw the NOT gate. Okay, it has a triangle with a small circle at the end of it. Besides that, for gate, there are a lot of other gates, okay? But for this chapter, for this topic, we are looking only at the 4 basic gates, okay? But the 4 basic gates can be combined in order to form a combinational logic circuit. So what is combinational logic circuit? Combinational logic circuits are made up from a basic logic gate, okay? For example, AND, OR, NOT, and XOR, then are combined or connected together to produce more complex switching circuits. Okay, in the slide, it shows one example of combinational of logic circuit. These logic circuits combine two types of gate. The first one, which is A and B go through AND gate, and then they are going through NOT gate. All right. And then the second one is show three gates be combined together. A are going through a NOT gate, B going through a NOT gate, then they're being combined in OR gate. Alright, the next one showing five gates being combined together. A going through NOT gate, B going through a NOT gate, then they're being combined in AND gate. Okay, after that, both of them are going through a NOT gate again, and then another NOT gate. This is an example of combinational of 5 logic gates. Alright, and then last one is another combination of 5 logic gates. Okay, there are 2 NOT gates, and then there are 2 AND gates, and lastly is 1 OR gate. Alright. Okay, that's it for today. Okay, thank you for your attention. So start each day with a grateful heart. Thank you, everyone.